In this example, we're going to look at how to calculate the magnitude and direction of a vector. Suppose we have a vector A. We could split the vector into I and j components, where I is across the page and j is up the page. To help us do some calculations, we'll label the horizontal distance p and the vertical distance q. So the magnitude of the vector A is simply its length. And so we have a right-angled triangle where A is the hypotenuse. So to find the length of A, we can simply do Pythagoras. So if A is PQ, then the magnitude of A, written like this, is the square root of P squared plus Q squared. To write the direction of A, we have to have an angle measured from some specified direction. So in our triangle, we could label theta, and if we were to write down the direction, we could measure it from the I direction, for example. Okay, let's do the example then and make things a little bit clearer. Okay, in this example, we're going to be looking at the magnitude and direction of vectors. There are two main parts to this question, and each of those parts has two subparts. So in part A, we're told that v equals 3i plus 7j. And first we need to find the exact magnitude of v. Let's start with a diagram. We have our vector v, which is going to the right and up. The vector goes 3 in the I direction and 7 in the j direction. To find the magnitude, we have a right-angled triangle. We can just use Pythagoras. So the magnitude of v is equal to the square root of 3 squared plus 7 squared. 3 squared is 9, 7 squared is 49, so we get the square root of 58. In part 2, we need to find the angle that v makes with the positive I direction. In this question, from our diagram, the I direction is to the right of the page. So we want to measure the angle between this dotted line and the vector v. Let's mark that on. To find this angle, we can use right-angled trigonometry. Relative to the angle theta, we have the opposite and the adjacent. Opposite and adjacent tells us to use tan. So tan theta is opposite over adjacent, which is 7 over 3. We can solve for theta using our calculator. If we do inverse tan of 7 over 3, we get theta equals 66.8 to 3 significant figures. When we specify a direction for a vector, it's good practice to describe where you've measured the angle from. So I'm just going to add in here from the positive I direction. Now, strictly speaking for this question, that wasn't really necessary because it told me where to measure the angle from in the question. Okay, here's a problem for you to have a go at for yourself. Pause the video and then come back and check your solution against mine. Welcome back, here's my solution then. Well done if you got it right. If not, I'll go through how I got my solution now. We'll start once again with a diagram. We've got a vector going to the right and up. We're going 2 in the I direction and 6 in the j direction. And while we're at it, we'll add in the angle theta. Okay, let's find the magnitude then by using Pythagoras. We get the magnitude of w equals the square root of 2 squared plus 6 squared. 2 squared is 4, 6 squared is 36, that gives us the square root of 40. We could leave our answer like that, but 40 is 10 times 4, so we could simplify this to 2 root 10. Next we need to find the angle that w makes with the positive I direction. We already have that angle marked here, and once again we have the opposite and the adjacent in this triangle, so we can say that tan theta equals 6 over 2. Which you could just write as 3 if you liked. So in our calculator, we need to do the inverse tan of 6 over 2, which gives us theta equals 71.6 degrees. and that's measured from the positive I direction. Okay, let's take a look at part B then. Right, in part B, we have a similar kind of situation, but this one does require a little bit more thinking. We have the vector s, which is -4, -9. So that means we're going to draw our vector travelling in the negative I direction and the negative j direction. We're travelling 9 units down and 4 units across. We won't mark our angling yet because that will require a little bit more thinking later. So let's calculate the magnitude. We need to do the square root of -4 squared plus -9 squared. If you want to just write 4 squared plus 9 squared there, that's absolutely fine. I'm just leaving the negative in to make it a little bit clearer. -4 squared is 16, -9 squared is 81, so we get the square root of 97. In part B, we need to find the direction of s, and we need to give our answer as a bearing. So the vector is travelling down to the left here. And to measure the angle as a bearing, we need to measure it from north. So our bearing will start at north and go all the way round until it hits the vector. So in order to find this bearing, we want to find an angle at the top of this triangle. To find the angle, we can use trigonometry. We've got the opposite and the adjacent again. So we get tan theta is opposite over adjacent, which is 4/9. If we put that into our calculator, we get theta equals 23.9. But as this isn't our final answer, we're going to leave that value on our calculator display and use it later. So to get our bearing, we need to start from north and go all the way round. We already have this part of the angle here. To get there from north, we need to make a half turn. So the bearing is 180 plus our answer to the previous part. And if we put that into our calculator, we get 204 degrees if we round to 3 significant figures. So here's one for you to try then. Make sure you draw a clear diagram, and then when you get to the bearing part, be careful about which angle you're actually trying to find. Okay, pause the video and then come back and check your solution against mine. Welcome back, here's my solution. Well done if you got these answers. If not, I'll go through how I got mine now. So our vector t is 1 minus 6. That tells us 1 in the I direction and 6 in the negative j direction. So down the page by 6 and to the right by 1. That should be enough information to find our magnitude. So the magnitude of t is the square root of 1 squared plus -6 squared, which is the square root of 37. In part B, we need to find the direction of t. Again, we're going to give our answer as a bearing. So let's mark on north. This time, the angle we want for our bearing is outside the triangle. But to get to that bearing, we're first going to find the angle on the inside of the triangle. To get that angle, we can use trigonometry. We have tan theta equals the opposite over adjacent, so 1 over 6. If we put that into our calculator, inverse tan of 1/6, we get theta equals 9.46. We're going to use that value later, so keep it on your calculator display. Let's add our bearing back in. So to get this red dotted angle here, we could start with 180, which would be the half turn, and then subtract the bit that we don't want, which is our angle theta. So the calculation we're going to do is 180 minus 9.46. If we put that into our calculator, we get 171 degrees to 3 significant figures.